Hello everyone, and welcome to the Experimental Seafood Processing Lab's Public Advisory Council meeting update. We had an exciting year at the ESPL, including 2 new hires, consisting of a senior biosafety researcher and an intermittent worker to assist the senior researchers with various experiments and tasks. There have been numerous projects, upgrades, and updates to the facility as well. Some of the research projects accomplished consist of catfish byproduct utilization research in products such as fish sauce, fish cakes, and fish balls. It was provided through the Department of Agriculture's competitive grant. Extending catfish fillet shelf life was made possible from the Department of Agriculture's Food Safety and Inspection Division. The Agriculture Research Service and Dr. Eric Staffney spearheaded the muscadine grape project. Soybean protein was enhanced to improve tofu quality. X-ray technologies were used to optimize food safety and quality. A novel process was developed to increase oyster quality through individual quick freeze technology after X-ray irradiation. Oyster Vibrio testing certification through the Food and Drug Administration. And a steam cleaning in place technology that greatly reduces foodborne pathogens in processing facilities. Dr. Sam Chang is the director of ESPL. He provides vision and leadership to the continuing development. He spends his time guiding senior researchers to novel experiments, editing scientific articles from other researchers around the world, and procuring funding so our work is able to continue year after year. And seeing as how on average only 1 out of every 10 grant proposals are funded, Dr. Chang's ability to procure more than 60 grants is extraordinary. His vision for a state-of-the-art aquatic food research center is currently in the works. As we know, science never sleeps. Dr. Yan Zhang has been tasked with catfish fillet and byproduct research and has done a phenomenal job with rheometer analysis. His studies include a suitable catfish shelf life, byproduct utilization analysis, and setting catfish meat gel to determine texture through different heating methods and temperatures, just to name a few. Dr. Zhang also has worked extensively with muscadines and soybean protein analysis. He is considered an expert in protein chemistry, flavor chemistry, and antioxidants. Dr. Benny Park was tasked with developing rapid Vibrio detection in oysters, which, as we know, is not only important to us locally, but all over the world for enhancing seafood safety. Dr. Park's detection system has been able to detect Vibrios in minutes as compared to hours, and without scientific labors or equipment in the oyster farms or processing facilities. Dr. Park practiced veterinary medicine in Korea and helped develop vaccines before coming to the ESPL lab last January. He is a true asset. Dr. Yue Wu was tasked with researching a novel clean-in-place system utilizing swiping steam and steam-jetted hot water, which would eliminate foodborne pathogens in food processing facilities and their surfaces. Dr. Wu has spent countless hours and numerous experiments determining the proper time, pressure, and water volume needed for effective sanitation. He also conducted research to determine the optimal hydrostatic pressure needed to produce a quality oyster that was not only cost-effective but safe. His studies on Vibrio inactivation through low-voltage X-ray irradiation are extensive. Dr. Wu also effectively controlled proper pH and water quality to maintain dozens of live catfish for Dr. Zhang's catfish research. Not only has Dr. Wu dedicated his time and efforts in implementing quality control for Mississippi State's Experimental Seafood Processing Lab, he spent over 18 years as a quality control manager in the largest MSG factory in the world, before taking the position with Mississippi State and furthering his education. The various facilities at ESPL are categorized as the Biosafety Lab, Analysis Lab, Quality Control Lab, our new chemistry lab, and the pilot food processing plant. In the biosafety lab, there are several systems used in detection and effective inactivation of biohazards. Dr. Park is hard at work every day researching how to keep seafood safe for consumption. The analytical lab contains the LCMS, which separates and identifies different components with high molecular specificity. This is used to analyze biochemical, organic, and inorganic compounds with precision. The chemistry lab has been newly renovated and equipped with new vent hoods, a Kajal system used for protein analysis, a -80-degree freezer, and secure lockers for chemicals needed to determine toxins in food and water supplies. In the quality control lab, there is a plethora of equipment used to determine protein concentration in different fish byproducts as well as soybeans. Dr. Chang works tirelessly calculating rheometer analysis, texture optimization, and elasticity thresholds of protein gels. In the food processing lab is where the largest equipment is utilized. There's the X-ray machine, the sanitation steamer, the can seamer, fish deboning machine, grinder, mixer, and several separate workstations to prevent cross-contamination. What you see here is our 300-gallon climate-controlled tank with an endurance 4,000 bead filtration system used to stop catfish harvest locally. The ability to collect samples from the water to the analytical lab within minutes is an essential key in efficiently analyzing protein and determining how processing times affect the quality of catfish fillets and byproducts. We even got to have a little fun catching the fish in the process. The whole process of cutting the fresh fish, grinding the fillet meat, extracting the protein, and reading the analysis results takes minimal time with our streamlined procedures in place. Finding the most economical uses of all parts of the catfish is our ultimate goal. After each experiment has been performed, effective cleaning must take place. Dr. Wu and his novel cleaning-in-place swiping steamer takes the effort and uncertainty out of sanitizing our cutting boards. Thanks, Yue. Here is a look at some of the other useful equipment we have in use. A water filtration is not always enough, so some experiments call for distilled water, and with our ultra-pure water system, we always have plenty. The IQF machine uses liquid nitrogen and can freeze samples in mere minutes. When a controlled environment is needed for optimal irradiation, this atmosphere box is utilized. Approximately $300,000 has been spent on new and upgraded equipment for the ESPL to keep research capabilities current. Through our research endeavors, we have built strong relationships with the Department of Agriculture's Research Service, Catfish and Agriculture Processors, the DMR, NOAA, the Food and Drug Administration, Mississippi Commercial Fisheries United, Alabama Fishing Industries, and professors from universities around the region. Our overall mission is to ensure food quality and safety through novel technologies and processes with innovative research to enhance the seafood, aquaculture, and agriculture industries. We welcome all who are interested in our mission to plan a visit to our facility. On behalf of all of us here at ESPL, we want to thank you for watching and hope you have a wonderful day.